Good afternoon. Today I'm going to talk to you about water and diseases. The current reality for water and diseases are that for diarrheal diseases, 3.3 million deaths occur per year. Those diseases which are related to intestinal worms contribute to 100,000 deaths per year. Schistosomiasis accounts for 200,000 deaths per year. Malaria accounts for 1.5 million deaths per year, for a total burden per year of 5 million deaths, all linked to water and diseases. Water-related diseases have different environmental classifications. They are fecal-oral, water-washed diseases, water-based diseases, and diseases that are linked to water-related vectors. Vectors are agencies of transmission. For fecal-oral diseases, pathogens or agents of transmission are moved within human excreta and then ingested. They then provoke infections of the intestinal tract, resulting in diarrhea, and in extreme cases can cause illness and death. Examples of fecal-oral diseases which are this extreme include the diseases of cholera, typhoid, and hepatitis. In terms of the transmission routes for the diseases of cholera, typhoid, and hepatitis, there are primary and secondary columns of transmission. The primary is essentially looking at the overall environmental reservoir where the disease itself rests, which is linked to the practice of open defecation or uncontrolled sanitation. These two in combination promote a cycle of contaminated water, which in turn is transmitted by flies, and in poor hygienic conditions or habits, also transmitted by hands if they're not washed after defecation, and even the soil itself becomes contaminated. And from there, it moves to the food. And from there, we have, from open defecation to this secondary transmission into the food, the ingestion of the pathogen. Water-washed diseases are generally linked to personal and domestic hygiene. In the image here, we see an example of domestic hygiene, which is maybe not the best in terms of food preparation, food storage. It's not evident what water storage is like here in this context, but if it's as well as the food preparation, there is some potential risk. In terms of personal hygiene, it's the usual hand washing after defecation, but also includes, as we've already talked about, some of the skin diseases, washing of clothes. Water-washed diseases generally are linked to skin and eye infections. They include skin sepsis, scabies, fungal skin infections, and trachoma, which can eventually lead to blindness. And others include louse-borne typhus. Water-based diseases are skin-penetrating or ingested, and they include diseases such as bilharzia and guinea worm, which we find in parts of Asia and Africa. Although in recent years the treatment of guinea worm has reduced the reservoir to only certain parts of Africa. Diseases which are spread by vectors are usually spread by the vector of insects, and they are generally insects that breed in water or that bite near water. Vector diseases from insects that breed in water some of them are very well known to us. They include malaria from the Anopheles mosquito, dengue fever from the Aedes mosquito, yellow fever also from the Aedes, and river blindness from the black fly. And for the insect vector that bites near water, we find trypanosomiasis or sleeping sickness from the well-known tsetse fly. In terms of transmission mechanisms and the strategies to apply, we link the strategy to the type of mechanism that is moving the disease. For waterborne diseases such as cholera, we try and improve the water quality of the drinking water, or we try and prevent the casual use of unimproved sources. Strategy for water-washed diseases such as scabies, we hope to increase the quantity of water that can be used by improving the access and reliability of, say, domestic water supply, but also to improve the hygienic practices of the population. For water-based diseases, such as the guinea worm, we look at decreasing the need for contact with infected water by providing alternative water sources for domestic water supply instead of using contaminated surface water sources. trying to control the vector with treatment of the water, and to reduce contamination of surface waters by uncontrolled excreta or poor sanitation management. Finally, for water-related diseases, such as the insect vector diseases of malaria and dengue fever, we improve surface water management to minimize standing water during the rainy season, which are the common breeding grounds for a lot of the insect vectors, try and destroy the breeding sites of the insects. And also applying barriers such as mosquito nets and indoor residual spraying to try and control and kill the vector on site. Essentially, the concept that we have to look at is that of barriers in terms of dealing with the diseases. And if we look at this diagram, commonly known as the F diagram of transmission routes, we start off with the primaries of the feces. Then we move to the second corridor of fluids, fingers, flies, and fields. And then from that, the next corridor of transmission is through the food and then into the host. And the basic rule of thumb in terms of dealing with transmission is to set up barriers, usually with hygienic practices and sometimes by treating or attacking the vector of transmission. So basically, we want to reduce the reservoir to interrupt transmission in order to prevent the disease in the population. If we're unable to do that, we have to treat the disease in the person at the end of the day. So either we deal with it at the reservoir stage to block the transmission to the host, or we end up treating the disease of the host who is then contaminated. So ultimately, in terms of diseases, whether they're water-washed, water-related, waterborne, or water vector, the concept of barrier and protection is one of the essential keys to dealing with these diseases for prevention. If we are unable to prevent the disease, then we have to move to treatment, which is more expensive and not always 100% guaranteed. Thank you.